Welcome to another episode of Alkira Design Zone. My name is William Collins, and I'm a principal cloud architect here at Alkira. In this episode, we're going to dive into Alkira's integration with HashiCorp's Terraform, and then we're going to provision some cloud networking with CI/CD pipelines. Terraform providers are really just plugins that give you the ability to drive an external API. Under the hood, you have Terraform Core acting as an entry point. And that interfaces with a provider like Alkira's, which effectively works as a translation layer that enables communication with many different clouds or infrastructure providers. So in the demo, I'm going to be using some Terraform modules. And the best way to think about modules is simply a way to group common resources together into lightweight abstractions that you can then reuse. And I would think of it like a general purpose programming language, say Python. You could copy and paste different bits of code together in different places, or you could write a function and call it when you need it. So with this module block right here, it closely matches the intake process that you would go through to onboard a new Azure Virtual Network. So you need to create the VNet and assign an overarching CIDR block, but then you need to carve it out into separate subnets for your different applications. And then you can connect it through Alkira and place it in the right segment, associate it with the right policy groups, and then apply the right tags. Let's give our workflow a quick look here. I have my infrastructure as code files stored in a GitHub repo, and I generated an API token from Terraform Cloud, and I have it stored as a secret. This will be used to make API calls to Terraform Cloud through their API-driven workflow. And in my versions file, I set my organization and workspace that I want to use as a remote backend. And this will offload my state management to Terraform Cloud while still giving me the ability to use my own existing CI/CD tooling. And with my GitHub Actions workflow, I have it set to trigger on pull requests to my main branch, which, like in real life, in the real world, typically matches production. And in Terraform Cloud, I created a workspace under the API-driven workflow type, and each workspace in Terraform Cloud has its own state associated to it. And also, one thing to note, you could use the Terraform Cloud webhooks with GitHub directly, but this wouldn't allow you to use your own CI/CD tooling. And then lastly, the Terraform provider is going to go out and interface with Alkira's API, and our networking will be provisioned. Here's a bird's eye view of the topology that we're going to go ahead and provision, along with a few requirements that we want to meet. Each cloud provider is going to get a dev and a QA network, and then Azure and AWS are going to get a production network as well. Dev and QA should be able to communicate inside and across clouds, but we want to keep prod isolated off on its own. And each cloud connected to Alkira gets a standard tagging scheme applied to it. So let's go ahead and get going with the demo. This is my repository holding my infrastructure as code files. And to use GitHub Actions, all you have to do is create a GitHub/workflows folder and then add your desired YAML configuration. And my workflow here is going to trigger on pull request, and it's going to run some checks to do some linting before it gives me the ability to merge. And this includes checks for syntax, spacing errors, or anything that's going to cause me problems when we're actually ready to provision the infrastructure. And once it's done running its checks, then I'll have the ability to merge. And then if we look at one of the infrastructure as code files, it's really simple. So we're basically just defining the name of the VPC and the CIDR range. And then we're going to break out the subnets that we need to provision for our applications. Just CIDR range, availability zone. And then we're going to define the segment that we're going to use from the Alkira perspective, and then the groups that we're going to use, and then the billing tags that we're going to apply. Now that our code is committed to version control, let's open up a pull request. Let's keep that naming simple. And now that that request is open, we should see, yep, there we go. GitHub Actions has come to life. And what is actually happening is in the background, GitHub is spinning up a build agent. And it's going to install my designated version of Terraform on it. And it's going to run the checks I have defined in that actions file. Okay, looks like it's finished. Let's go back to that pull request. And we can see from our workflow that our format and style are good. It successfully did an initialization, validation, and a plan. And it looks like we're ready to merge. Let's go ahead and click the button. Now that our code is merged, or it's getting merged, we should see Terraform Cloud come to life now and start to plan. So we see the plan is queued here. Let's go ahead and open up this workspace. Yep, okay, there it is. And it's going to go through now and provision our network infrastructure. So we can expand this to actually see all the details in real time. I'm going to go ahead and set this to full screen. And again, each Terraform Cloud workspace here is actually an independently managed state file. And in practice, HashiCorp recommends to create a workspace for each environment of an infrastructure component. Okay, it looks like our provisioning was successful. Let's go ahead and hop over to the Alkira portal and validate our infrastructure. And there is our cloud network infrastructure. So what is really amazing here is we created a common network across the three major cloud providers and have separation set up across a few application environments, all from that single CI/CD pipeline. So let's poke around and make sure everything we wanted to accomplish from the requirements got completed. So let's take a look at segments. And as a refresher, our segments are layer 3 isolated routing spaces, kind of like a VRF. So think of them as a macro level segmentation. And here we can see our segment that we defined got created, and all of our cloud networks are added. So now switching gears, let's take a look at the groups. And another refresher, our groups are geared towards micro segmentation, where I can group like entities and then apply policy against them. So here's the two groups we defined. All of our non-prod cloud networks are correctly associated with our non-prod group, and the same for our production ones. So let's go back to the design canvas, and we want to make sure that the tagging scheme that we wanted to apply got applied. So let's check one of our non-prod networks here. And we can see these tags, cloud, and then network, and then non-prod. So non-prod looks good. And then let's check one of the prod networks. And again, cloud, network, and then the prod tag. Lastly, we want to validate our policy. Alkira's UI is great, and one of the awesome things specifically is how you can visualize policy. We want to ensure that our non-prod networks can communicate with each other both inside and across clouds. And then our production networks can talk to each other, but are isolated from everything else. Alkira in this integration with Terraform meets you where you're at today. So if you already have a CI/CD pipeline set up, no problem. We don't change the way you have to authenticate or how you do things today. Alkira can just be another step on that pipeline. If you're interested in learning more, feel free to reach out and we would love to chat. Thank you.